just got back from Open Sauce, and this is the badge from Open Sauce. It has, they're calling this the eyebrow. I think sopracciglio or something means eyebrow in Italian maybe. Yeah, that's the badge. That was kind of fun. And there's some add-ons for it. I don't know where I set those. Oh, here they are. You can like make little accessories for it. I might do something with that someday. I didn't have enough time to turn this into a time badge. But today I'm back and I'm going to try to solder this guy. I've never done one of these on my own here, a surface mount board. There's a couple through-hole parts on it, but my plan is to get this going with this hot plate, reflow it on the hot plate. And I got my box of all the components here, and I contacted Robin from Robin's Tools. He sent me this pixel pump too after I talked to Sean Hodgins. He said, oh, you should get a pixel pump. And I said, oh, I'll try to get one. And then I got in contact with Robin, and he was like, no, why don't I send you the pixel pump too? It's coming out soon, and I'm going to try it here. It comes with this little guy. It's off right now, but a cool thing is if I want to turn it on quickly, I can just press on here. That turns it on, and then I can start sucking up little things. So ideally you suck up circuits and not other stuff. But anyway, that's the pixel pump. My goal today is to see if that is more helpful than just using tweezers for some of these tiny components. I'm also testing these guys out. DigiKey, if you order 2 of a component, sometimes they come in an entire reel. And I took the bits off of the reel and I loaded them into these guys, which are Robin's Tools little magazines, SMD magazines. These are the 12 millimeter ones. They also have 16 millimeter, so I have a bunch of these, and for future projects, I'll probably start using them more. For now, I don't have too many. I have like 10 of these and 2 of these. So that entire spare bit of stuff is just empty, and there's 2 in there. So DigiKey must have like millions of these reels just sitting around with like no components or something. I'll have to figure out what to do with those. In the comments, what do you do with extra reels after you're finished with them? Because I don't have a place to stick those things. Yeah, but that's the plan. I have a ChipQuick SMD291AX. I bought this like a year ago for another project, and I have never actually opened this up. The temperature curve on it is kind of high. Honestly, for hot plate reflow, I would imagine that using the lower temp stuff, SMD LTL FP, the bottom one here, that might be better. This one is, which one do I have? I have the 91AX, that's the top. So that actually requires up to 235 degrees Celsius. This guy says it goes up to 400. I don't want to get that hot in here. That seems a little dangerous. Oh my, Pixel. Got a few of these guys. This is the wrong size battery anyway, but I have another larger Pixel here on this one. This is what we're going to be building, and it doesn't work in the studio in this space with this antenna, but I can always jack it into my GPS antennas over there. I can plug into my outdoor antenna. So we'll do that later to see if this works, but I have 2 of these PCBs, and I think what I'm going to try to do is do the first PCB with paste and then just the tweezers, and then the second one with the pixel pump too, to see if that's actually easier. So let's get things set up and going. And this workbench, a sign of a workbench that's actually used is where you don't have any space whatsoever on it, and that's kind of the case here. This is also the first time I'm trying out, wow, that probably looks really ridiculous. This is also the first time I'm trying out the DJI Pocket 4 in this scenario as an overhead camera. So we'll see if this works or not. You know what? I should probably set up a second camera just in case this doesn't work. The coolest thing for me about this project is this was the final motivation to load up KiCAD on my Mac, and I think this is version 10. I think I'm getting into this at a good time because KiCAD seems pretty polished. There's this neat little 3D viewer over here that I can look at the board. The interface seems pretty snappy and not like unintuitive. I'm gonna have to get used to all these different buttons and what they mean. It's like every new bit of complex software. Add on to that the electronics knowledge that you need. But KiCAD has a cool feature that Sean was showing me where I can actually like highlight the board parts, and it'll show me exactly where they are on the board, so that it should be easier for me to see where everything goes. I could still wire up something backwards, but at least this should help me as a quick reference. And it's always nice to have a screen right next to you while you're doing your work. So I have this little Mac Mini set up under the desk here. that we use for reference when we're doing projects on the main workbench. Well, I realized I was not recording at all for that, I don't think. So we're going to try to put these. This first one, I tried to put some solder on the little itty bitty pads. I could not get them to line up. I couldn't hit each pad with this little guy. So I'm going to see if bridging them like this will work with the capillary action kind of putting it apart. But I have a feeling that I might have some contacts that are a little bit bridged here. I might have to do some cleanup work here. That's hopefully going to be fine. I don't know, we'll find out, but I think I got all those. So now let's start placing components. Here we go, C2 through C5. So these are the first things that I'm going to try to do. Get these out of here. I'm going to do this first one all by hand. Okay, C1, C2, C5. Do it like this. Okay. All right, now we're looking for C1. Those are like the very end. I think this is one of the LED resistors, probably for greeny. That looks bridged. We'll see how these turn out. I'm sure some people in the comments are already screaming at me about something. That's okay. Sometimes mistakes can be a little expensive, but you know, if I ruin 50 bucks worth of parts, that's not the end of the world. But I'm hoping if I do mess up this first job, I can still recover it by repairing the board afterwards. I must consult the book of SMD components. These are all 06. Oh, here we go, 08, 05. And I need two of these, R7 and R8. I think the pixel pump would be much better on here, but this will work. This should work okay. Oh. Let's get one of these here. Release. Oh boy, smearing this everywhere. Man, oh man. All right, hopefully that works. I trust in you, capillary action. Okay, that is every device on the list. So tell me, what do you think is going to happen? I think that we might see some bridging in those contacts. We might see some bridging here. It's not the best picture quality with the little Osmo Pocket here, but that's what I did. We're going to try to reflow this on here. I need to get the cardboard off of it because that would be an instant fire. We don't want that. But we're going to try to reflow this. Maybe I should do this not here at this workbench, just in case I need to throw something outside quickly. Okay, so here's the plan. I have this aluminum foil here and my thermal camera. As you can see, I can look at the aluminum foil, and right now it's 25 degrees Celsius. I'm going to try to somewhat follow this profile for the AX. So we're going to get up to 100 degrees Celsius by 30 seconds. We'll see if we can get up that high that quickly. And then I'll set it up to 235, and we'll see if we start a fire. I have my fire extinguisher over here. I've used this thing to 100 degrees Celsius, never more than that, so hopefully we don't start a fire. The actual value you can't see. I'm holding this as if it's a camera, but that helps you not at all. It's I have it set to 100, and the actual is 60, 61. So let's see, the board is warming up. The board is at 50 degrees. 51, so the board is heating up here. Let's see if you can see that. We're waiting for the thermal mass of this thing to come up. We're at 70 degrees on the board now. The thermal paste is definitely kind of skinned over a tiny bit. I have a feeling that I put far too much on everything though. I really hope that capillary action sucks that back in, because right now it is, we're bridging a lot, that's for sure. You know, just to be safe, I will put on safety glasses. Always a good idea with dealing with hot stuff. You only get one set of eyes, and you never know what's going to happen. I definitely think it's a good idea to use the lower temperature solder if you're doing hot plate. I see smoke. I'm wondering where that smoke is coming from though. And so far I'm okay with this, but I'm a little nervous. I'm going to open the door for ventilation over here. Turn on my exterior fan, because that's a lot of smoke. And I'm hoping that this is just off-gassing, because I've never run it this hot. We're at 160 on the board. I'm going to get some fresh air inside. And yes, I'm very glad I did not do this out in the main studio space, because we're getting a good amount of smoke coming off of the hot plate. See all that? I'm pretty sure that's just whatever gas is on this plate that's coming off from getting hotter than 100 degrees Celsius. But the PCB itself is getting hotter and hotter, but not yet reflowing. A lot of those bridges are resolving themselves as things heat up. Most things have fixed themselves. I'm probably going to have to do a little cleanup on the U-blocks and on those little comparators. I say comparators in my head, so if that's wrong, so sue me. The SMA connector has not reflowed yet, so I think we're going to have to wait a little bit on that. I don't want to leave things too hot for too long though. So the board's up to 200 degrees, hottest up by those connectors. I think we've off-gassed most everything at this point. There are some bridges in there. We're definitely beyond the time scale for this. This says 210 seconds. It's been like 10 minutes so far. So there's a good chance we're also cooking a couple of these circuits a little further than they're supposed to be cooked. There's definitely a couple bridges I need to fix, but we're at 250 on the control panel, and I don't have my Kapton on here, but the PCB itself has only gotten up to like 205 degrees. So that's a little alarming. Why are we not getting... I know there's more temperature coming out of this thing. And I have this timer here that I didn't even turn on. That was kind of silly of me. I could at least have been timing that, but the camera says it's been 15 minutes. Still only 203, so something... It's not quite transferring through to the PCB. Maybe it's sinking in. Oh, I see that the SMA connector back there is finally starting to reflow, so I guess the board is just soaking up all that heat. And having a full oven might be the best option here instead of just the hot plate. But I think I'm going to stop it there, and then we'll fix a couple of the bridges that are obvious, and I'll look at it under the microscope. Okay, so under the microscope, you can see there's a ton of flux. I'm going to see how easy this is just to clean off, or if I'm going to have to do more rework on here. But I'm just going to get some alcohol and rub it over this stuff and try to get some of this flux out of here. The fear I have is that I didn't get up to 230 degrees Celsius, which is where this solder wants it to be. I might try to get off a little bit of the excess solder and then see what I can do to clean this up a little further. I think that we can get this thing working. It might not look perfectly clean, that's for sure. I'm going to try to fix this bridge right here with a little bit of the solder wick. I found this technique on NanoFix, great YouTube channel that I've followed along with for a while now, trying to learn little soldering techniques and desoldering techniques to make it so that you don't saturate like this whole thing with heat and get this whole thing heated up. You can cut off just a piece of it and use, well, two things here. One is if you cut it at an angle here, I can kind of dip it in a little more precisely. And two is if you have it a short piece of this, like this guy, you don't have to heat up like a lot of it to get heat into a joint to clean up some solder. I also need a little flux, so let me get out my flux here. All right, so I'm going to put a little bit of flux on there. And let's get some solder off of here. Okay, we fixed that bridge at least. Yeah, there's definitely a bridge over here. Okay, I think we got that connector mostly cleaned up. It's not the prettiest, but not pretty and working is better than pretty and not working, I guess. 16 minutes of rework. It's a good thing I'm not manufacturing these things. So note to self, the technique of just putting a bunch of solder paste across everything results in a lot of cleanup work that I'd rather not have to do in the future. So don't do that next time. Just put it on the pads. Okay. I think we fixed that bridge. The last step is to see if this powers on. If it does, we might be golden. So comments on YouTube are not always amazing, but this is one tip that I was told on my video about restoring that PowerMac G5 Xserve setup, that if you're just brushing, you're just wiping stuff around, but if you want to gather it up, get some Kim wipes. And these Kim wipes seem to be cleaning it up at least a little bit. Let's see how this looks after all that. What's the saying in carpentry? Caulk and paint make me the carpenter I ain't. Alcohol and Kim wipes make me the PCB soldering expert I ain't. Look at this little joint. That's like the worst solder joint ever. It almost stovepiped where it like turns up on its side. But hey, if it's making connection, look at the little LED there too. Yeah, I put too much on. I think that the lesson here is less is more when applying solder paste by hand. But I think this is going to work. I think we're going to be okay. So I'm going to find, I can't do the Pixel, sorry about that. I'll do one of these guys, Energizer. And we're going to see if this works. This could go horribly wrong, but we're going to find out now. Oh, I might want to turn this off. Okay, turning it off. We could cook this thing or not. Okay, we got the battery in. If it works, then these lights will light up when I turn it on. They lit up. So the next step is I'm going to plug in my GPS antenna connection here, and we're going to see if we can get a PPS out of this thing. And yes, the clocks, they be multiplying. I have more clocks that I'm going to be putting into the mix at some point. The nice thing is I can see PTP, NTP, internal, NTP, external, GPS, direct, and I want to have some more clocks too so I can compare multiple time servers internally. Anyway, that's not what this video is about. This video is about this guy. So let's plug it in, turn it on. So we got the blink at startup, and you really can't see that. So let me bring this camera a little closer. I should have brought a longer wire with me, but whatever. All right, within 10 to 30 seconds, we should start getting a PPS blink. That'll tell me that this U-Blocks is working and we didn't torch it completely. I'll move the camera in a little bit close. There we go. We got a blink. I made a working PCB, my first ever try. Just had to spend 25 minutes cleaning it up. So now I know that I can do this here at the studio And that's pretty cool. I haven't tested the output on here, but I presume that that's going to work too, because the GPS module is definitely working at this point if we're getting the blink. For the first board, I was using SMD291AX, which, if you recall, it's this temperature profile that goes up to 235, and I could only get up to like 204 or 205. So I was never in that range where I think it wants to be to finish off the soldering, and that might be why I think some of the flux was just kind of boiling on the board and not going away cleanly, and I had to spend some time cleaning things up to get this to work. In the past weekend, I went ahead and ordered some of this SMD LTL FP, which if you look at this chart here, this is this one, and it only needs 165, which I can definitely hit, and I can probably even hit it within 3 or 4 minutes, so a little longer than this time period, but I think this lower temp solder paste might work better. The other thing I did was I looked online, like, how do you hit these tiny pads? Like, there's some pretty small pads for the 04s. And I was like, I just give up, and so that's when I made the little line across, which can work if you put just the right amount on, I think, but I don't want to have to do that. I want to just hit each pad. So I found out that you can just buy a huge kit of all these different sizes, all the way down to, I don't know which one is the smallest, but this one is pretty tiny. If you look in this kit that comes with the chip quick, you get a green and a little metal one. The metal one is huge, so that's for larger pads. But the green is pretty small, but it's not small enough to really hit these tinier pads. So I'm going to try, I think this one might be too small. I can't even see the end of it. Probably need the microscope to see how big that is. That one might not let anything flow through it. So I'm going to try to find whatever is the next size up from that. That's definitely a lot more precise, and I tried to not put too much on. There's a couple pads that I'm a little iffy on, but we'll see. Proof is in the pudding. I'm going to use the pixel pump to place components on this guy. We're going to start again with C2, C3, C4, and C5. This time I'm going to try the pixel pump. We're going to grab these parts right off of here. The pixel pump has different tips as well. This is the default green one that I put in. I think there's a smaller and a larger one at least. But I'm going to try to place these guys. These go, according to the map, here, here, and 2 down here. So let's see if this is quicker. If I just pull the strip off, and I can, so we're working here, I can grab one and put it. Well, that wasn't perfect. I got to get used to this. All right, let's grab another one. Okay, that was better. I'm sure that armchair critics will find more things to criticize me for here, but that's okay. I'm learning. Please put in the comments anything that I am doing inefficiently or wrong, or if I need the different tip size for these little components. These are all 0804 or 805 or something. Yeah, 0805. So they're small, but they're not the smallest. They're not like that diode, which I found here and I flicked it off because I thought it was dirt this morning. That was the wrong idea. Now that diode is somewhere on the floor and will get sucked up by the vacuum at some point, probably. So grab this. R1 goes right here. Okay, I'm gonna see if the pixel pump can lift up this SMA with air. Might need a bigger head for that, but let's see. Yeah, we've reached the limits of its lifting capacity with that guy. Just wanted to see. I didn't expect it to work. All right, place you by hand. I think we're done there. We just have these guys to go, and I'll do those later since they're just through hole. I'm gonna see if I can reflow this on the plate. I have a layer of aluminum foil that's supposed to like spread heat out a tiny bit more evenly or something, also to prevent spatter from boiling off flux. I don't know how much that helps or not, but let me know in the comments if you do this a lot and if this is a good idea or not. I'm gonna put you down on there and turn this guy on. And while it's warming up to, 60, I'm gonna go to, I'll knock it out to 100. All right, so that while that's warming up, I'm gonna go grab the little temperature profile thing and take a look at it. All right, and this time I'm actually gonna use my timer. So we want it to get up to 90 by 90 seconds. So I might actually need to turn that down a little bit, but we'll see. It takes a little while to get up to temperature. So we're actually following this temperature ramp pretty closely right now, which is nice. And I'm going to come back with my thermal camera too and take a peek at that. Okay, the PCB is up to 75, 76, so it's getting warmer. 82, 83. The solder paste is skinning over a bit. I'll just get a close-up shot with this camera so you can see what I mean. That paste is kind of skinning over a little bit, and soon it will start to turn into more of a metallic shine as it reflows. Hopefully around 130, 140. So I think I'm going to go up now to 165. So the PCB lags behind by 10 to 20 degrees Celsius. So 180 should be good for this, but it's going to take a while to get up to that. I'm going to go to 200 on here. That should get us into a region where we start melting this stuff. I'll get a close-up shot and see if we can see it actually melt. But we should start seeing these little guys go soon. Let's see what the temperature is on here. We're up to 140 on the PCB. And it's definitely gonna be getting there. Oh, look at that, it's starting to go. Okay, so you can see some of these. See how it turns from that kind of glazed look to shiny. That's what we're looking for. We're also getting some smoke coming off of here. Yeah, I think this is working out well. We're still waiting for these guys over here. There's a lot of thermal mass in there. Looks like those pads are also forming up over there. So I think we're doing good. I think I'm going to turn this off now. The board made it up to 160, 158, 160, and we're at 6 minutes, 59 seconds. So we're a little bit longer. It takes longer to heat this plate up, but we're past this point, so I'm going to put it down. I'm just going to turn it back to 60. And let things cool off. But yeah, this reflow looks a lot better than the last one. So I have learned, don't put too much solder on, don't just stripe it across. Let that cool down and we'll check it out on the microscope. Okay, close to a catastrophe here. I am heating this back up because I was dumb and I was moving this around to cool it off quicker. And then this guy started falling off, and then I hit this and it knocked a few components out of the way. So now I'm heating it back up just on the plate itself quickly to try to get these back in line and re-soldered down, because this guy, half of it was coming off. That was dumb. Don't move it until it cools down. Okay, note to future self. Okay, the board is cooled down enough that I can touch it, and let's take a look on the old microscope. It looks like, yeah, there's one pad over here. Can you see that on the U-blocks that needs a little extra solder? This side on the right looks fine. There's a couple with a little less than I'd like, but it's fine. Every other component looks like it is soldered well. The switch, one of those pins is missing a little bit, so I might flow a tiny bit on there. This is where I had the trouble. This part of the board must have lost heat much more quickly than this side, because this side I could kind of move around. You can see when I accidentally knocked it, it just flicked all that solder right over to the right. And when I did that, it knocked this guy off, it knocked some of these resistors off, it knocked the capacitor, it knocked that little fuse right there, so I'll have to clean those up really quick. I was so close, I would not have had to do any rework, just clean this thing and be done. But then I had to go around and move it, which knocked that out of whack. And then when I moved that guy back in line, this guy got out of whack. And then when I moved it, it flicked off and knocked all these other things. That was dumb. I think that this low temperature solder is not quite as sturdy anyway, so we'll see how that holds up with this guy. That connector is pretty heavy. I might need to put a new coat of solder on at some point if that rips off. We'll see. But yeah, we'll see how this goes. I'm going to clean it up a little bit and fix those joints, and we'll see if this one works. Over here, I have this one connected up to this Adafruit FT232H breakout board so I can plug it into the computer. I'm working on some software to try to visualize the GPS data out of here. And this is working, but not perfectly yet. So hopefully that's not like a bug with my soldering. Hopefully it's just a bug with my software. But yeah, I'll get this cleaned up and be right back. All right, let's see if this board works. The one that I did second after learning a bunch of things, and then also unlearning the lesson of let it cool down first. We'll see if everything is working together. And this one is on too, so let's turn that off. These switches are all on by default from the factory. Seems like that could be a risky way of building things. Let's see if we get a blink. If I can turn it on. We got a blink. All right, I'm going to plug in GPS, and it should take 30 seconds or so to get a signal on here. I clean this with a little more alcohol. There we go. We got a blink. So we have 2 working watches. This is great. And you know what they say, a man with 1 watch knows what time it is. A man with 2 watches is never sure. Well, that's why I now have 3 watches, in addition to all my other clocks and timing gear. You could say that things have escalated. I am using a Tapper GNSS antenna splitter. This was sent to me for testing by the Tapper project. I'll try to remember to link to them, but they make also a little time interval counter that I'm testing out. That has nothing to do with this, except for I needed a way to get 1 GPS antenna signal coming in out to 3 watches so that I can actually know what time it is. I have this one plugged into the computer over here. I'll show you that, but you might notice there's a maze of wires here. All of the PPS outputs are being fed into my oscilloscope. Oh, hello there. I'm triggering on the rising edge of number 1, so if I hit a single shot, we can zoom in and see that these are within, this is 10 nanoseconds, so these are all within 20 nanoseconds of each other on the PPS outputs. So the GPS antenna I'm using is outside, and it's a very good signal. So we're getting a clean signal, we're getting within 20 nanoseconds of each other, which is within spec for these U-Blocks modules that we're using here. So good job on Sean for picking some good modules. And then I'll show you what's plugged in over here on the computer. So on the computer, I have this little web UI that I built with the assistance of Claude. With some obvious bugs, this is AI slop code, so that's how it is. But I can get data like the time data out of it. I can get the satellite sky view data here. So these are all the satellites that I'm using on this module. If you hover over one, it'll show you the data. So it's using some Baidu satellites, some GPS satellites. I think it might also be using, let's see, here's one. That's Baidu. What is this one then? Galileo. So it's using 3 constellations. I think it might also use GLONASS, but I don't see any GLONASS on here right now. But anyway, it's just showing you all the cool stuff that comes out of this module that we can get access to. And in this case, it's using the little quick connector over here through this little breakout board. But as I showed in my open source video, I can actually get this into my GPS badge, the time badge that I made, and get more accurate time through the U-Blocks than I can through the older GPS chip that I was using on that badge. So I think for next year, this is going to be more of the setup that I'm going to be needing to run. We'll get there. I don't think I'll put all these on my wrist, but I might have like a big antenna on a helmet going into this guy, broken out into 3 modules going into 1 system that will compare the clocks and get the right time. Right now on the computer, I'm only getting the time from 1 of these. I'm doing the PPS up here, and that's showing us that, I'll do another shot here. And we can see that these are closer to 10 nanoseconds off from each other. There's still about 20 total. But yeah, that is the setup, and it's all working now. And I have 3 watches, so nobody can accuse me of not knowing what time it is anymore, except I haven't written anything to compare the time from these 3. So I guess I still have no idea what time it actually is. And in the end, what is time? It's just an agreement by a bunch of governments. So make up your own time.